Everyone. In this video we'll learn about the concept of AND, OR and NOT gates. This is important for the understanding of logical operators as well as bitwise operators. We have three logical operators: logical, AND, OR, NOT. Similarly, we have three bitwise operators too, named same: bitwise AND, bitwise OR and bitwise NOT. So here is a logical table for AND operator. You have to refer 0 as false and 1 as true. In bitwise we would use 0 and 1, and in logic we would use 0 as false and 1 as true. According to AND, if both of the operands are true, then only the expression simplifies to true. If either one of the operand is false, if you have one of the operand as true and another as false, then it simplifies to false. If operand on left is false and the right is true, then also it would simplify to false. And in the case where both of the operands are false, we have the answer as false. The only case where AND operator simplifies to true is when both of the operands on either side are true. Let us have a look at OR. According to OR, if either one of the operand or at least one of the operand is true, then simplify the result to true. So there would be only one case where both of the operands are false, in which we would get the result as false. If operand on left is false and the operand on right is true, we get the result as true, as at least one of them is true. An operand on the left is true and the right is false, we get the result as true. And for the case where both of them are true, we get the result as true. This was OR gate. In case of NOT, we change the state from false to true and true to false. If the operand is false, then it shifts the value to true, and if the operand is true, it changes its value to false. This is the logic for NOT. Here are few examples. 5 greater than 3 and 5 less than 10. This is logical AND, which is used to club multiple relations. In this case, we have two relations clubbed by AND. So the relation on the left, 5 greater than 3, simplifies to true, and the relation on right, 5 less than 10, simplifies to true. And according to AND, both of the operands should be true in order to simplify to true. The first expression would result in true. Second, we have 10 not equal to 11 or 10 not equal to 13. 10 not equals to 11, which is true. Logical OR. On the right hand side, we have another relation, 10 not equals to 13, which is also true. So OR operators simplifies this value to true, as at least one of the operand should be true in order to simplify to true. Third example, we have a bracket 404 less than or equal to 200. 404 is neither less than 200 nor equal to 200. Therefore, the expression inside bracket is simplified to false. The NOT operator changes the value of false to true. Therefore, the final answer is true. 404 less than 200 gives us false. 404 equals to 200 also gives us false. Therefore, this is false, which is reverted to true by this NOT operator. Fourth example, 400 equals to 400, and we have another expression on the right, 119 greater than 100, which is true, which gets reverted to false. True and false. According to AND, both of the operands must be true. We have true on the left and false on the right. Therefore, we get the simplified value as false. Now we have 123 greater than equal to 1985 or 1 less than 2. 123 is neither greater than 1985 nor equal to 1985. Therefore, the expression on left simplifies to false. On the right, 1 is less than 2, which is true. According to OR, if at least one of the operand is true, it would simplify to true. False or true simplifies to true. Now we have concept of precedence and associativity. The rule of precedence is required in programming language. It is similar to the one which we study in mathematics for evaluating equations. We have a rule of Bodmas, by which the order of evaluation is brackets of division, multiplication, addition and subtraction. In same way, we have precedence rules for operators in programming languages. There are way more than just arithmetic operators in programming language, and there has to be rules by which the order is specified, the order in which they would be evaluated. and we have precedence, then why do we need associativity rule? First, let us have a look at precedence of operators. Here is the precedence table. First, we have scope resolution operator, which we are yet to see. It is found in C++. Then we have post and increment and decrement operators. We have function call, array subscript. Most of the operators you would be unaware, but we would cover it soon in later series. Here we have a few arithmetic operators, multiplication, division, modulo. Then we have left shift, right shift, bitwise operators. Here we had relational operators. So in this table, the topmost operators have highest order of precedence, and the bottommost have least precedence. Therefore, multiplication, division, and modulo would be evaluated before addition and subtraction. And here we have logical and logical OR. Here we have compound operators. Here we have relational operators which reside above logical operators. Therefore, relational operators would be evaluated before the logical ones. Now, if we have the rules of precedence, why do we need the rule of associativity? The rule of associativity is required when a particular operand is associated with both operators having same precedence. Like we have in the fifth row number, multiplication, division, and modulo. If a particular operand is supposed to do multiplication as well as division with another two operands, then associativity rule helps us in determining which of the operation would occur before. Now let us have a look at an example. 5 into 7 modulo 2. Here we have three operands, 5, 7 and 2. The operand 7 has two operators associated, multiplication and modulo. And in the table we have seen multiplication and modulo are at same precedence level. So which one would be simplified before? So according to the rule of associativity, the execution would go from left to right. Therefore, in this case, 5 into 7 would be evaluated before and then followed by modulo. 7 5 is 35 modulo 2 results in 1. Another example, 7 into 10 by 5. Here too we have an operand 10 associated with multiplication and division. According to the associativity, we would evaluate this expression from left to right. 7 times the 70 by 5, which gives us 14. Third example, num1 equals to num2 equals to num3. We haven't seen such expression till yet. Let us have a look at assignment operator. Here is the assignment operator. Its associativity is from right to left. Therefore, num3 would assign its value to num2, num2 would assign its value to num1, and this is the way how this expression would be evaluated. So associativity is required whenever brackets are not explicitly specified in an expression. Let us have a look at an example. Here we have an expression 7 in 5 asterisk 7 modulo 3. According to the associativity left to right, the expression would be evaluated. Another expression 7 into 10 by 5, same arithmetic operator, associativity is left to right. And in the third example we have ans equals to n1 equals to n2 equals to n3. Here the associativity is from right to left. n1 is initialized to 2, n2 is initialized to 3, and n3 is initialized to 4. So 4 would be assigned to n2. Then n2 would assign its value 4 to n1, and n1 would assign its value 4 to ans. Therefore the output would be 4. Let us run the program. Open up a terminal, java c precede.java, and interpret it using Java interpreter. So we get 2, 14 and 4. 5 7s are 35 modulo 3. 11 3s are 33, which leaves a remainder of 2. Another example, 7 10s is 70 divided by 5 gives us 14, and we have seen this example. The resultant is 4. n3 assigns 4 to n2, which later on assigns 4 to n1, and then finally to ans. Therefore we get answer as 4. Thank you.